Hello, this is Carsten OZ9 Alpha Alpha Radio. Um, just a short video. I have created a small application called SimpleCalc, which is mostly for EME users. It's an application that will calculate the cascaded noise figure of a system with up to 2 LNAs, cable losses, and antennas, and so on. And it will also try and predict, or at least give you an idea of what sun noise you should be able to receive on your system based on a number of parameters. I'll just go quickly over the application. You can find it very soon on my webpage www.moonbounce.dk, and you should be able to find it in the menu here under SimpleCalc. The application is, as I said, a simple application that tries to calculate some parameters of your system, and it should predict the amount of sun noise you should be able to receive. Now, there is a lot of applications out there already that does this. I made this application in the hope that somebody else could use it, and I learned a lot of things making the application while debugging my own 70 centimeter EME system. There is an application out there which I guess pretty much everybody knows, EMECalc by VK3UM, which is sadly a silent key. EMECalc has been around for many years and has been my default go-to application since 25 years when I started on EME, which I had a break from for many years, but that's another story. EMECalc is very detailed and has a lot of information, and it takes many parameters into the equation, and it can be, for some, I think, a bit overwhelming, as there are so many things you need to understand and be able to use. So I thought maybe it was an idea to make something a lot simpler. Now, when you do this the simple way, you will lose some of the accuracy that EMECalc has. Doc and the people who have worked on EMECalc for many years has made this application more and more precise and more correct. And my application SimpleCalc can in no way match that. What it can do is it can, at least I hope it can, give you some ballpark figures of noise figure and predicted sun noise. There's quite a few things that it does not take into account, but at least it will give you a rough estimate of how your system is performing. So with that out of the way, on the web page, as I said, there is a short introduction and a disclaimer with one very important thing is that you can be absolutely sure that there are errors in the program. It is brand new, and although I've had a few friends test it for me, there is always something that you didn't think of. And if you find something, please let me know. Send me an email or another way, get in contact and tell me what's wrong. I got a lot of input from the nice people on the MoonNet email reflector. Some of the brightest minds are at home there, and they are incredibly wise and experienced, and I learned quite a bit from direct mails and contacts, and also by reading all the many posts on the MoonNet reflector. This is basically how SimpleCalc looks. I will get back into that and show you how it works. The web page explains the screens and the windows and some of the details. Some of the details are, I hope they are they're explaining themselves as again. I hope I made it simple, but you never know. The windows are basically, the program has 3 windows. The main window, the solar flux window, which I'll get back to, and then a comment window, which is basically just a simple editor for taking notes and so on from your system. And here you can very soon download the SimpleCalc application. So this is the web page where you can download it, and let's get the program up and running. When you download it, there's no installation files or anything. You simply download one single exe file, and you place that into some folder of your choosing. If you double click the program, it will start up, and it will create its own configuration file within the folder where you started it. This configuration file you can copy, and you can rename it. You can make several configurations if you please. So this is just a simple way of starting it. No installations or anything. Once you start the application, it will start up with a number of default numbers. There are some things you need to do in order to get going. You need to enter the data or parameters for your system, the antenna gain, the losses in the antenna, that is from the connector and into the antenna. This can be balloons, insulators, anything that in somehow contributes to losses in the antenna. And you also enter the effective antenna temperature, noise temperature. In this case, it's set to 40 Kelvin. Some of the data here are from my system, the gain of my EME and array, losses, relays in front of the preamp itself, the gain. The preamp is a 2-stage preamp, so the second stage is actually included in those data. I have some line loss to the radio, and I have a noise figure of the radio of 15 dB. That's an ICOM IC 9700 with the internal preamp off, and that gives the radio a noise figure of 15 dB. You have a number of fields up here. You have the solar flux value for the band you are going to calculate. Solar flux data, we'll get back to that. You select which band you're interested in, and then are the results over here, the noise figure from the antenna connector to and including the receiver. You have the complete system noise figure, temperature. You have the G/T, and you have the expected sun noise. Right now the numbers are not giving much sense, especially the expected sun noise, as we don't have any solar flux data active in the system. The noise figure is accurate. That's 0.64 dB. The next screen that we are going to pull up is the solar flux data. We can put this over here. The SFU data is fetched from NOAA. They have a number of measuring sites where solar flux is measured, the 10.7 centimeter, and a number of other frequencies are measured. And the first we will do here is fetch newest data. And a few things happen here. First of all the rows here got populated. Rows with the -1 means that there are no data available from that site. A row with pink or red background color is data from yesterday. This is from Hawaii, which was released at 2300 UTC. Right now, when I'm recording this, the time is 11:43 UTC. So this is old data. And if you look, yeah, this is actually not 12. It's a glitch in the data. I think they are published at 10 UTC, which is 12 local time in Italy, because the data here are present. These numbers, as I said, are fetched from NOAA. There is also a row where you can enter your own data. You can simply type the SFU values for each of the frequencies. That can be from historic data or some other way. You get the actual data. You can put it in here and use these data. To the extreme right, you see the solar flux value for each of the ham bands from 50 megahertz to 10 gigahertz. On the top here, it shows the source of the data right now. You can see this is from Learmonth. It is the use button is green. That's because the data is used. If I press this one, the data changes. You can see the curve changes. I will explain that in a moment. And data from last day, from yesterday, and so on. Also, a thing you should notice is that whenever I change the solar flux data, you can see the solar flux value on the main window changes dynamically. And also the info box here telling you where the data is from is updated. The data in this area here is what is transferred here. So if I select another band, you will see that for 1296, if you go here, the value is 131, and back to 432, which is 48, which is what we have here. So this is how the solar flux data is downloaded and used. On the top, it will show when the data was issued by NOAA, and also the current time. The interpolation box, I will get back to that in a few minutes. On the bottom here, you see a graph which shows basically two things. The first is the blue lines or the blue dots. Those are the values from the site that measures the SFU or the solar flux values. So the values for 245, 410, 610, and so on, they are shown here in the blue dots. Okay, so this is the data that are measured. The orange dots are the interpolated values for the ham bands. See, it starts from 50 megahertz and goes all the way up to 10.3 gig. You have 432 here in the middle, 52, which is the value you see here, and also the value you see here on the main window, 52. You can see the orange line follows the blue line, or tries to. And And the way it follows the measured data can be, you can actually choose between two methods. You can do it using splines, where you make a spline, a curve, and fit that to the blue measured values to interpolate and to extract band-specific solar flux values. Or you can use what I call line, which is actually it's a simple linear interpolation, so that if you have, for instance, if you have 2.3 gigahertz, it will draw a straight line between those two blue dots, and it will interpolate the value, the SFU value, 172. This is two different ways of doing it, and I'm not sure which one is the best, if any of them is the best. I can just see that people on the net are basically doing it either with splines or with the linear interpolation. So I decided to implement both, at least to start with. You are very welcome to comment on this and to give any suggestions or reasons why you shouldn't use one of the other, or why you should use the other one. It's just another way of trying to find the correct solar flux value for the ham bands, and that's basically what it is. So let's get on with. I think this is pretty much for the solar flux data. Everything will be remembered when you close down the program. If you press the save values as default, you can see if I change the value, it will light up in green. This means that you can press it, and the next time you start the program, all these parameters will be the same. And these parameters are saved in this configuration file, just as a note. If I go ahead and do a lot of different things, and I regret, I can just say load default values. I will get back to the values as they were before. You can also save or load the settings from a file. Basically, if you save and load, then it's everything on this screen and on the comment screen, which I will show you in a minute. The solar flux data are, you need to fetch that or to enter them manually if you have that, but everything else will be remembered. I can try and do a load here, and I can load. Basically, that's not much change here, as that was the same data pretty much. However, we can open up the comment box, which I said is basically just a very simple editor, where you can write. The idea is that when you do multiple sun noise measurements and so on, you can record it in here, and keep it for the future. It's a simple editor that can do pretty much what you would expect. You can change font, you can change colors, you can do bold, underline, and so on. Yeah, this is, as I said, it's just a simple way of taking notes and to have them a centralized place. That was why I added it. Again, the values here will be saved if you press the save default, and you can save everything to a file, and then everything is remembered, and you can, if you go ahead and and load some other files. You can work on that, and once you're done with that, you can revert back to whatever you were doing. Um, so that's the idea about the save and load function. That's pretty much it. As I said, it's simple. At least I hope it is. It's probably buggy. Uh, there must be some bug hidden somewhere, I'm sure. There always is, especially around the SFU data. There's a lot of things that can go wrong, data that can be missing, and so on and so on. But I think and I hope that I covered most of the situations. But feel free to download the program. It should be available when you see this video, and let me know if there is anything you think that is not working correctly or things that could be improved. The program might in the future contain some more features, maybe features like how strong should my echoes be, or how strong should I hear this and that DX station and so on. But for now, this is what it is, and this is pretty much what you get. So I hope you enjoyed it, and let me know what you think. Thanks for now.